Now we'll take a look at Kirchoff's current law, which is also called the junction rule. And it's really just that at a junction, which is where wires meet, the current flowing in is equal to the current flowing out. And I've seen this expressed in two different ways. One way is to say that the sum of the current, so we use Greek letter sigma, the sum of the current in is equal to the sum of the current out. And another way to write this is to say that the sum of the current in minus the sum of the current out is equal to 0. Whichever approach you prefer is perfectly fine. So as a quick example, looking at that, do you remember we had an equivalent resistance question where I wanted to know if some resistors were in series, where we had R1 coming up, and I'm going to imagine that there is current flowing upwards. So we have I1 going through R1, and then after that the wire turns to the right, and then it splits off in two different directions. So we have R2 on the top, and then we have R3 on the bottom. So I1 continues through the resistor and then makes a right turn, and then it splits. So we have I2 going through R2, but then we have a different current, I3, going through R3. Often on this circuit diagram, I would label the junction. In this case, I would call it junction A, just because using the letters, lowercase letters, tends to not clutter things up too much on the diagram. If I label that, then I can say at junction A, the current in is equal to I1, and the current out is equal to I2 plus I3. Or if I'm using the second form of it, I could say I1 is positive because it's going in, and then I would have minus I2 because I2 is going out of junction A, and then I would also have minus I3, and that all adds up to 0. Either of these, it's basically the same equation. It's just a matter of whether I have grouped all of the current terms on the left-hand side, or if I have all positive current flowing in equal to all positive current flowing out. Either of these is fine. The key points to getting this right are first to show the current direction on your circuit diagram, and you don't have to get the current direction right, but you have to be consistent. Often what happens is you find out after you solve for the unknowns that one of the currents, or maybe more, maybe all of them, are negative. And if that happens, you don't have to change the answer, presuming your algebra is correct, but what it means is that the current is actually positive, flowing in the opposite direction to what you had guessed on the circuit diagram. The other thing that you need to do as a key point is to make sure you label the junctions for your equations. And the reason to show the current direction is to really help you get the equations right. The reason for labeling the junctions is actually more to help the person who's grading your work understand what you're doing. So you can think of it as if you help them understand what you're doing, you're helping them give you the grades. Because believe it or not, professors actually do want to give you the grades. They want to recognize that you understand what's going on and give you the grades for that. And labeling the junctions and taking other steps by writing neatly and blah, 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 other things, you can actually improve your grades just by helping them understand or helping them realize that you understand what's going on.